Okay guys, for this tutorial I'm going to show you something fairly simple. It's basically just a script that will disable an object if it gets within a certain distance from the player, as you can see in the scene view up the top there. And when the object gets close to the player again, it re-enables it. So the purpose of this script is to try and help you optimize your worlds a little bit. If you've got a lot of objects in them, something like this will help you out. You can add the script to disable an object to any object you choose, so you can exclude objects from being disabled if you don't want them to, and you have a bit of control over the distance as well. It kind of acts like a draw distance, only not quite, just sort of like that. I've had this script working with object amounts in several hundreds. I think in one of the games I was working on, I had this working. It had about 600 or 700 objects that the script was working with, and it seemed to run fairly good. I was still getting around 80 odd frames a second just using it, which is pretty good when you've got 800 odd objects in your scene. So hopefully if you're struggling with this, or if it's something you're working on at the moment, this is just a very simple way of implementing something like this, so it should hopefully help you out a bit with your own games. Alright, we'll get started. Alright, so now that you've seen what we're going to achieve here, I'll show you how it's done and the scripts that we'll need to write to get it all to work. It's very easy, it's very straightforward, and it's quite flexible too. So if you're having problems within your game, if you've got a lot of objects, a lot of prefabs, all getting spawned at runtime, that kind of thing, and you're finding that you're losing some frames per second as a result, you'll find writing something like this will be very, very helpful for you. So ideally you want to try and avoid having too many objects in your world, but I know it can be unavoidable at times, so if you are in that situation, you should find this will help you out. I've created a few things in the scene already just to save a bit of time. You probably didn't want to have to sit there and watch me create all this. So all I've got is just a big flattened out cube that I'm using as the ground, which I've called floor. And I've got a bunch of little blue cubes in here, which I've saved a prefab of called cube. And I've just got them all added as children to a cube holder object. So if we drop that down, you'll see them all there, all 80 of them. I've just got them in there to keep things a bit tidier, so you don't have to, we're not looking at that all the time. Alright, we'll get into writing the scripts. It's going to be very, very straightforward. In a folder called scripts I've got here in the project, I'm going to create a new C# script, which I'll call ItemActivator, or whatever, that works. Yep. Cool, open that one up in Visual Studio. Only going to need a couple of variables. Which are going to be pretty straightforward. What we'll do, first one we're going to add is, we will say serialized field, private, we can make it a float, no, let's say int distance from player, we'll call it that, sounds good. We're also going to store a reference to the player, so we'll say private game object player. And one more, now this is going to be a list. What we need for a list, anytime you want to use a list, if you haven't used one before, I'm going to go back up here to under using system.collections. We're going to add a new line, using system.collections.generic. And that will just allow us to use the list item in our games. And lists, if you're not familiar with them, are really, really useful things. They're kind of like arrays, but they're a bit more flexible. They allow you to sort of add things and remove things on the fly, and they'll sort of sort themselves out automatically. So if you add a new item to a list, it'll just tack itself on the end of it, whereas with an array they generally have to have a defined size, and you generally need to tell it where to add things and stuff like that. So I just find lists are really useful little things, and you can sort of work with them fairly easily. So we're going to add a new one of them. We'll just make a private list with the 2 arrow brackets there, and the list is going to be an activator item. Now it's not going to recognize that at first, but don't worry about that, and we'll say activatorItems as the name of it. So, as you might have noticed, it doesn't recognize that, and you're probably wondering what that is. Well, we're going to create that. That's going to be a class that we create of our own. At the very end of this script, so after the actual ItemActivator class ends, as you can see there, we're going to add at the bottom of this our own custom class. So we'll make it a public class activator item. And whoops, I'll add a start curly bracket there. And it's auto formatted for me, whatever. What we're going to chuck in this is 2 things. So we're going to have a public, not a public, we're going to have a public game object, which we'll call item, I guess, and we will have a public vector3, which we will call item pos. So if you're not familiar with classes, it's pretty straightforward. Basically everything in any script that you create in Unity is generally a class. A class can have within it any collection of information that you want. So in this case we're just creating our own class of item, which we are calling, sorry about that one, we are calling an activator item. So each instance of an activator item is going to have 2 bits of information in it. It's going to have a game object called item, and it's going to have a vector3 called item pos. So we can now work with that class. The way we're going to do that is in our start function. We are going to find the player and store a reference. We'll say player equals GameObject.find player, which is what I've called the FPS controller, so that should find the only player in the scene. And we're going to not instantiate, we're going to initialize, that's what I'm looking for. We're going to initialize the activator items list, and we will do that by saying activator items equals a new list of activator item. Oh, end with 2 brackets, finish. There we go. So that's basically saying, yep, you've got a list, let's initialize it, and it's going to contain activator item. Pretty straightforward so far, hope you're with me. Alright, next thing we're going to do is do a start coroutine, and the coroutine we'll call it check activation. Sounds good. That's all there is to it. Alright, we'll get rid of the update function, don't need that one. Instead we're going to have an enumerator, or a coroutine, which we'll call check activation. Give it the 2 brackets. Have I got that? Yep, that's right. Cool. Okay, first thing we're going to do is create a new temporary list. So same as before, we'll say list. It's going to contain the activator item. Same as before. We'll call it remove list. And this will make a bit more sense in a bit, so bear with me. And we'll once again initialize it by saying new list activator item, brackets, finish. Under that, we're going to have an if condition. We will say if activatorItems, so that was the first list we created, you can see it highlighted there. So if that list's count is greater than 0, so in other words, if there is actually something in this list, then we're going to go through that list and perform and do a couple of things. So we will say for each activator item, which we'll call item, in the activator items list. So for every item in that list, we're going to do the following. We will say that if vector3.distance between the player.transform.position and the item.itempos, so that's basically getting the item in the list, and then it's checking that value we created before, the item pos. So remember, that's going to store a vector3, so that should tell us once we finished, when we add things to this list, it's going to have a game object and that game object's location. So what we're doing here is checking the distance between that item in the list and the player. So if that distance is greater than, what are we going to say, the int that we created before, distance from player, so we'll define that a bit later, and we'll, oops, I think, get that one back there. So if this item is further away from the player than the amount we define there, and what we're going to do is we are going to say if item.item equals null. So in other words, if something's happened to that object since the last time we checked the list and it no longer exists, then we are going to say remove list.add item. Now what that's doing, so basically, if you're not aware, when you're working with lists, because we're iterating through this list, we can't just directly remove an item from it. So what you'll see in a second is that instead of going through the list and for every item we find that's been destroyed or disappeared for some reason, instead of just removing it directly from the list, which we can't do because it doesn't let us, we're going to add it to a second list, that list being the remove list, and then once we're done all this, we're going to go through the remove list and remove it all from the original list, the activatorItems list. If that doesn't make sense, I apologize. It is a little bit weird, but bear with me, you'll get there. So we're going to add an else to that condition. So if the item isn't null, if the item still exists, then we're going to say item.item, which is the game object of item. Sorry, that's really poorly named, I apologize. We're going to say set active false. So there it is. Basically, if the item contained in that activator item entry instance would be the word. So if the actual game object in that activator item instance still exists and it's further away from the player than we want, so further away than the distance from player value, then we're going to basically deactivate the item. We're going to set it to disabled, which we do there. Which is pretty straightforward. So for that if condition, the if vector.distance, we're going to say else. So in other words, if it isn't far enough away from the player, if it's close to the player, we're basically going to do the same thing. We'll say if item.item equals null. So if the item has been destroyed, we're going to once again remove, remove list.add item. So bearing in mind the difference there between the original item, which is the activator item instance, and then the item there, which is the actual game object within that instance. Once again, I apologize, it was a really bad naming choice. And we'll say else, same again. So if the item does still exist, then item.item dot set active true. So in other words, if it's close to the player, then reactivate it. Good. So, alright, that's pretty straightforward. I think that's all we need for that. After the for each, what we might do is just add in a yield return wait for seconds, new wait for seconds, which we'll set to, I don't know, 0.01f. It's just to add a quick little pause in there, otherwise it can get a bit laggy sometimes if you're going through these lists constantly. Alright, cool. After we've done that, we're going to do what I spoke about before, and that is, now that we have gone through that list, so we've checked it, if any items were found that have been destroyed, so let's say, you know, one of these cubes gets blown up since the last time it was checked in the list, then what we're going to do, or what will happen, is that item.item will become null. So if that happens and we try and set it to active, it'll give us a null reference error. So to avoid that, if it's null, we're going to add it to the remove list, and then we're going to go through that remove list here. So we'll say if remove list dot count, same as before, if that count is greater than 0, then for each activator item, I'll do it again, item in remove list. So for each activator item in remove list, we're just going to say activatorItems, so the original list, dot remove item. And that basically just removes it from the first list. So it frees up that space, it gets rid of it, we don't need to worry about it anymore. And there we have it. Alright, cool. So we'll now go yield, return, new, wait for seconds, 0.01f, and we'll start the coroutine off again. Start coroutine, quotation marks, check activation. Oops, don't need brackets, what am I doing? There we go. So this is just going to loop infinitely while the game's running. Well, not infinitely, you know, whatever. It'll just keep going. And so every time it runs, it's basically going to check the first list. It's going to see if any of those objects are far enough away from the player that they can be disabled. If they are, it disables them. If they're not, it just basically re-enables them, which won't matter if they're already enabled. And if any of them get destroyed since the last time it checked them, then it'll add them to a second list. And then once we're done checking this list, it'll go through the second list and then remove them from the first list. Awesome, that wasn't confusing at all. Sweet, that's all there is to that script. So that's our ItemActivator script done. It's It's nice and easy, very straightforward, and it's covered quite a few cool little things. So, you know, creating your own class, and using lists and going through those lists, and sort of, yeah, the funny little quirks that they have. Now that we've done that, what we're going to do, let's create a new empty game object in our scene, which we will call ItemActivator object, just so there's no confusion. I'm getting bad at that, my apologies. So we'll drag and drop that script onto it. So if we have a look there, we can see the distance from player variable. Let's set that to, we'll start with 10. We'll see how 10 goes. Cool. Now it's not going to work yet. We need one more thing. Let's go back to scripts and create a new C# script. What will we call this one? Let's call this one disable if far away. That'll do. Open that one up. Cube. Yeah. Alright, so for this we're going to need a few more variables, nothing too fancy. What we'll do, we'll make a private game object, which we'll call ItemActivator object. It's going to store a reference to that object we just created. We'll say private, what will we call it? ItemActivator, which I think was the script. Yep, it is, good. And we'll just call that one activation script. So we're storing a reference to both the object and the script attached to the object, so that script we just wrote. Now that we've done that, I think that's all the variables we need. Awesome. So in start, let's fill those two variables. So we'll say that the ItemActivator object is equal to gameObject.find ItemActivator object. There we go, and the activation script is equal to ItemActivator object.getComponent. What did we call ItemActivator? That's the one. Cool. So basically we're just storing a reference to the script attached to the ItemActivator object, the script we just wrote. Excellent. Don't think we need update. I think we can probably do it in start. Shouldn't matter. Let's do it in start, that'll work. So under start, let's just say, it's very straightforward, it's like one line, which is going to say that activation script dot activator, hang on, I didn't make it public, did I? 1 second, I didn't. Let's make that list under the ItemActivator script public. Otherwise we won't be able to access it from the other script. Good job me. Alright. So just change that one there. Let's go back to the disable script. So activation script dot activatorItems, which is that list, and we're just going to we're going to add, and under add we're going to create a new activator item, so that class we created, curly brackets, and in that we're going to say that item is equal to this dot game object. Then we're going to have a comma, and then item pos, which is that vector3, is equal to transform dot position, so the current position of the object that the script is attached to. And that's it. That's all there is to it. That right there is the whole system working. Just need to, so what we do is take that disable script, and we're just going to attach it to any objects that you want to disable themselves at a distance. So in this case it's only the cube. So all I got to do is drag, drop that on the cube prefab there, and hopefully that should update these cubes. So if I have a look, there they are, disable if far away. And that's it. So just to go over that again, when an object starts, so when one of these cubes starts, all it does is it finds the ItemActivator object, finds the script attached to it, and then it adds itself, or it adds its game object and its position to the list, the activator items list on that script. And as we know from that script, if it has objects in it, it just goes through them and it just checks their distance from the player, and if it's far away it disables them, and if it's not far away it re-enables them, and if anything happens to those objects it removes them from the list. That's all there is to it. So what I'll do, I'm going to take the game view and I'm just going to drag it down here. We don't really need to look at that one. Going to, from the scene view, let's just zoom out a bit so we can actually see this working. Get up a bit like that. And as long as I haven't stuffed anything up, this should work nicely. So let's play, and oh, look at that, it's not working. Why isn't it working? I've gotten an error. That's okay, let's have a look at it. Object reference, not set. Why isn't it set? Let's have a look. What's it complaining about? That's okay. What have I done? I've done something wrong. ItemActivator. Maybe I've named it wrong. One sec. Let's go back up here and have a quick look. ItemActivator object. Did I... No, I added the script to that. That's okay. One sec, guys. I'll work this out and I'll be right back. Alright, sorry about that. Got it sorted. So, figured it out. What's going on in our disable if fire away script? So basically all this is running on start, but if we have a look at the item activator, it doesn't actually initialize the list until this object starts as well. So pretty easy way around that. We just need a little bit of a pause before it actually finds, before it tries to start adding items to it. Because yeah, if the list isn't initialized and all those items try and add themselves to the list, it's not gonna work. So pretty straightforward and easy way to get around it. What we're going to do is create a new coroutine, IEnumerator. We'll say add to list is what we'll call it. There we go, and we're just going to add this line to that coroutine, and we'll say right before it yield return new, wait 4 seconds, and we'll just make it 0.1f. Doesn't matter, only needs to be a tiny little pause. Probably even be shorter than that, whatever, it doesn't matter. And in start we're going to say start coroutine, add to list. So it just waits for 0.1 of a second and then it adds itself to the list, which should give it enough time, or should give the item activator script enough time to actually initialize that list for us. So my apologies, when I wrote this script before, most of my objects were being generated into the world after the game ran, and then adding themselves to the list, so yeah, I kind of wasn't expecting that one. All good, all sorted, it's what it's all about though. So if we give that one a test now, we should see it working. So we'll give it another go. Let's say play. And if we run around in the game, well, first of all, we'll notice, bam, all the items have disappeared. And we can sort of see in the game view down here, it's like just the 4. So let's run around a bit. You can see the player moving there on the scene. And there you have it, look at him. Now that's not perfect, just because you know that's a pretty small radius around the player. So let's bump that up and we should have a better idea. So we'll just end the game. We will go to the cube object. No, we won't. We'll go to the item activator object. Well, let's just bump this up. Let's say, like, how big is that cube? 100 by 100. So let's make this. Let's make it 30 and just see what that's like. And we'll just run it again. Yeah, there we go. So that's a bit better. There you go. So it's kind of like a draw distance, I guess. Only not quite. It's sort of doing similar things. So basically, if an object's far away from you, it's not active, it doesn't do anything, it's not in the world. And then once you get closer to it again, it just re-enables it. You can see it doing its thing there up in the scene view. So I mean, in a tiny game like this, you're not really noticing anything with it. It's not making a big difference. But like I said, when you've got a lot of objects, like if you've got some randomly generated dungeons or worlds or whatever, they could have a lot of objects in it, especially if you're using prefabs for your walls and floors and stuff like that. So it really helps. Like you will see noticeable FPS increases. So in the last game I was working on, if I generated a large world, I was getting about, I think, 5 to 10 frames a second when I was running it. By implementing this script and attaching it to virtually every object that didn't need to do anything when I wasn't around, it shot right back up. I was getting like 80 to 100 FPS from it, so it can be quite useful. And it will take a bit of tweaking. Like you may find you have a few problems with the script later on if you start trying to do some different things, like if you've got objects that do things over a long period of time, and you walk away, those functions and methods might halt, but there are ways around it. You can tell it to pick up where it left off, or you can tell it to exclude certain components. So if you've got a script running on the object and stuff like that, you can tell it to leave that active and just disable everything else. You can do whatever you need. But other than that should be enough to get you through for most simple games. And if you're not trying to do anything too crazy and intense, you'll find this could be quite beneficial and will help you to sort of start working on a system that will hopefully allow you to improve the running of your games and to make them a bit less intensive on resources. Yeah, that's all there is to it, guys. So as always, thanks for watching. Please like and subscribe if you want to see a bit more, and I keep trying to get these tutorials out. It just can be a bit hard to think of things sometimes, and thankfully we kept this one pretty short so far. So yeah, thanks for sticking with me. I'll see you next time.